everyone, welcome back to this data science series. This is our fourth lecture of this series in which we are going to cover data preparation phase to model the data. In the last video we have covered about exploratory data analysis. We have learned about hypothesis and cleaning of the data. Now we are going to learn about data preparation phase to model the data. In this lecture, we'll explore the data presentation phase in data science, which will focus to clean, transform and partition the data for effective model building. Why data preparation is crucial in data science? The question arises in our mind. But why is it really important, right? Because it improves the data quality and it improves the model performance, the two factors which we desire. Next, it is done by partitioning the data into training data set and testing data set. What is training data set? It is the largest portion used to train the model according to the name, training set. And testing set evaluates the model performance on unseen data. It evaluates or tests the model performance. Again, as the name suggests, and a validation set which fine tune model hyperparameters. We are gonna continue with training and testing sets. Now, balancing the training dataset in Python by oversampling, it replicates minority class examples, and by undersampling, it reduces majority class examples. Both can be happening. Then we can build cart decision trees using Python. But before do that, let's have a look on the code of the partitioning data. So partitioning the data can be done by splitting it into testing and training subsets as we learned. Here from sklearn.model selection we are importing train test split, which is the function from this package, and pandas as PD. Now again in data we are storing our data set, then partitioning the data using in X we are storing and in Y we are storing the target variables as, and we have the data sets variables like xtrain xtest, ytrain ytest, and train test split is the function used here where train is partitioning the data into training set and test is splitting the data set in test variables. So this is how it is done by setting the test size as 0.3 and random state at as 42. We are printing it and this is what it looks like. We are printing the training features which are 2 3 3 0 1 5 3 4 2, and these are the testing features. Now let's have a look on cart decision trees, my favorite part. So what are cart decision trees? Can feel that sometimes we have the parameters like, for example, we have sunny, rainy and windy as temperatures, and one has to decide that whether or not he should play football outside. Like it is quite predictable using decision trees because we are using uh, preset data values. Like obviously the weather is going to remain same. In windy it will be wind, and sunny it will be sunny, and in rainy there will be rain in outside. And certain more parameters like weather, temperature, humidity, these are the parameters which are used. So according to those parameters we can use either Gini impurity, or we can use another methods like ID3. These can be used to construct our decision trees. So CART is a classification and regression tree. Classification is in categorical data and regression tree in numerical data. Recursive partitioning is done. It splits the data sets into subsets based on attributes, as I said, like it can be weather, temperature, or these are examples. There can be different more examples. And then we find Gini impurities of each and these. So the least Gini impurity in which of the attribute is selected, and so on the process is continued. How to build a C5.0 decision trees using Python? Let's have a look on that. First we can look on cart decision trees. This is building card decision trees. From Escalando tree, import decision tree classifier. We are importing it, and then we have this xtrain and ytrain values. Then card tree is the variable we took here. The decision tree classifier is a function where criterion is Gini index. We are using here Gini index, and random state is set to 4. Then we have card tree fit as xtrain and ytrain. Then we can print that it is trained or not. So let's see whether it is or not. Yes, our card decision tree is trained. Now let's have a look on C5.0. What is C5.0 decision trees? It is like more wider range. Uses information gain, like I said, ID3 information gain, which is using entropies to calculate. It is an extension of CART algorithm. CART was introduced first, then we use C5.0 decision trees, then we use random forest, which we'll cover later in this lecture. Now we are looking on C5.0 decision trees, which uses entropy and information gain, and then pruning is done. Pruning is like removing the branches which are not necessary or which have not played important role in decision trees. Pruning can be uh, like deleting or cutting them off those branches. It reduces the complexity and overfitting. Let's have a look on the code. This is the code of C5.0 decision trees in Python. We have C5 tree as a variable. We have decision tree classifier, a function. Criterion is entropy. In earlier we have said is Gini. And here also random state is 42. C5 tree dot fit, using fit function to xtrain and ytrain values variables as attributes, and then we have printed, like if the code is executed it will print that C5.0 decision tree is trained. Let's have a look. Yes, our decision tree is trained. Now let's look on random forest. What actually is random forest? Like, it can sound lame, but think of it like tree is a single. Like when there are more trees, a lot of trees, then it is called forest. Isn't it? Is it simple? But it is so simple. But we can see the same philosophy here, using so many trees resulting in random forest in Python. Like see, 100 ensemble learning in multiple decision trees, 1000 random subsets, and 10,000 majority vote. It can be the prediction. So these are random forest, compiling many decision trees into one as the output. Evaluating model performance can be accuracy, precision, recall, and F1 score. These are the parameters which can used to evaluate the model. But first we can see the code for our random forest. This is the code to build random forest using Python. It is an ensemble method that builds multiple decision trees and averages their predictions. As I said, multiple decision trees are two and their predictions are averaged. We have from sklearn.ensemble imported random forest classifier. Then again we have data frames. Then we are building the random forest using RF model function random forest classifier, storing in RF model where the attributes are n estimators 10 and random state 42. There may be 10 trees. RF model dot fit, using fit function in xtrain and using xtrain and ytrain attributes, and here we print a random forest train if our code is executed. It is executed. Next steps can be hyperparameter tuning, feature engineering, and model deployment. So this was it about this lecture. In the next lecture we will learn about model evaluation. Thank you for watching this video.